Welcome to Shortly Physics Force on a Conductor Lab. This is a measurement lab. We're going to attempt to measure the magnetic field strength of the two magnets in this force apparatus. So it's comprised of a couple of magnets with conductor bars, and these bars are going to be hooked into a battery. Now this cross beam is placed on the two bars, and it's free to roll back and forth, such that if we apply a current, put a current through that bar, and try to get this parallel perpendicular there, and put a current through there, it begins to roll. Now we're going to have it roll to the left because in this procedure we're also going to elevate the track, and our goal here is to try to find a balancing force such that gravity, the component of gravity going down the track, is going to balance the amount of force, the magnetic force pushing up the track. And that way we'll be able to determine the magnetic field using F equals Bill, magnetic field times current times the length. Now the length we're going to be using is from where the bar touches here to where that crossbeam bar touches down here. That's going to be our length. And I'll have to get that measurement. I haven't gotten that one yet. I do have a few measurements here. We do have the length of the bar is 17.3 centimeters, that rolling bar. Its mass is 13 grams, and that converts to 0.013 kilograms. Now, as far as my procedure, I've drawn a sketch here. Angle is a very difficult value to get because it's just so small and it's difficult to measure from a table. So I'm going to use Star Wars. This one is Jedi Search by Kevin J. Anderson. Very good author. He also writes his own stuff. But I'm using this book to calculate the angle. See, I'm going to put the book underneath the edge here, and using a formula up here with the number of pages. The number of pages is going to relate to the height, and that height will relate to the sine of theta. So I figured out here that there are 194 pages, and I've accounted for 2 pages for the width of this paperback. But all in all, here's my little formula. If I start from the front of the book, that's going to be about 6 pages plus whatever page number I turn to this way, divided by 2, because there are 2 page numbers on each slice of paper. Okay, so with this little formula, I figured out there's about 1.366 times 10 to the negative 4, about 0.1366 millimeters is one page width. So if we get the number of pages and multiply by that figure, look at the height, and use a little trig to figure out our angle. So that's the procedure I've come up with, and we're going to do a few data trials, one after the other, and I'm probably going to piece these video segments together. So I'll see you in just a moment.